Hello, everyone. My name's Adam Tettleman, and I am a product architect from NVIDIA. So I'm going to talk today about BaseCamp and the NVIDIA DGX Foundry, which are two programs that are sort of new, and we're going to market, partnering very closely with DGX Foundry. So I'm going to touch on that at the end. But a lot of what I'm going to talk about today builds off of what Mike started off with around the MLOps layer, and then what we talked about with Max at the data science, what you're actually doing. And then I want to talk a little bit more about what David just brought up with all of these different stacks. So I'm a product architect, and I've had a lot of interactions with customers, helping them build out a lot of custom solutions or deploying third-party softwares or full stack solutions. And a lot of the times it starts off with a POC. And it's, I want to set up Kubeflow, and I want to just see how this works. But where I've seen a lot of people have trouble is when you're actually trying to build something that's not a POC, and you want an enterprise-ready AI stack. And so you would think I'll just get the MLOps layer, I'll have my storage solution, I get something that will hook them together, and I'm good to go. But it's never that easy, and when you jump into it thinking it will be that easy, you run into problems. So BaseCamp was NVIDIA's solution for this as a platform. And so I'm gonna back up a little bit and talk about how NVIDIA is an AI company. So most people, they know NVIDIA makes GPUs, and most data scientists know that NVIDIA makes SDKs, platforms, but we build a lot of AI within NVIDIA as well. We have our consumer products, we have our enterprise products, and we have natural language processing models that we build. We have super resolution, denoising, style transfer models that we build in-house for our products or with some of our partners. And we've been doing this for years now. And all of the issues that we talked about today, they're all issues that internally as a company we've had to solve. We've struggled with them, and this is that story. So we started less than a decade ago with our first server, the DGX1. And shortly after that, we launched Saturn V. We announced that it was our internal supercomputer, and it was a top 500 system. Over time, we've played around with the software stack internally. We've made a lot of mistakes. We've learned a lot of lessons, and we figured out how to scale up the hardware, how to scale up the cluster, but then also how to interface the software into that. And so it's been a long story. We played with OpenStack, we played with Kubernetes, and we played with Slurm, and we have a few different clusters internally. But what we've ended up doing is we've centralized everything. We've built our AI center of excellence within the company. And all of those products I just shown today, this is what we use internally at NVIDIA to build this. And so what is Saturn V, which is our internal AI supercomputer? We've got massive amount of nodes. We have millions of training jobs that we have run, and we have thousands of data scientists using this on a daily basis. We have AI researchers, we have interns, everyone in between is using this platform, and we're able to enable all of the different types of AI workloads within the same ecosystem. So we found it really useful internally. I know I was really excited when I got onboarded to it at first a few years ago, and we're now externalizing it and making it available as a product.
So the NVIDIA Saturn V is A100 GPUs, or is it Hopper?
So it's a mix. So right now it's A100, and I think that there's a white paper out there that has more details. But Saturn V is less of a single cluster, and it's more of an evolving cluster. So this is sort of where we put our new hardware, and we're able to, over time, and this is actually one of the great things about Foundry, is over time we can put new things in there and enable it at the software layer without having an impact on the data scientists that are using it.
How much data storage are you sitting on at Saturn V, and what kind of storage is it? Is it the E series, or is it the ONTAP?
So for Saturn V specifically, I don't know the details for that, but we can share the details around the DGX Foundry. So some of Saturn V, the specs, it's our internal cluster, so I can't necessarily talk to that. But we have a mix of different things.
Okay. You mentioned 2 million AI training jobs.
Yep.
Is that like over the course of an hour or course of like?
So I think that's over the course of, I think, a year.
A year.
But you go in there and it depends on what you're doing, because some of those training jobs are hyperparameter optimization searches where you kick off 100 jobs and they run for 30 minutes. Some of them are 500 node big NLP jobs that run for 2 weeks and train a massive model. So it's kind of a vanity metric, but the cool thing is it's everything in between.
Those jobs that run for weeks, you're checkpointing on a periodic basis.
Yep.
So you don't lose data.
Yep. And so at the software level, that's a really important point. We need to make that easy for data scientists to do. And I think going back to what we said earlier on in the day, they shouldn't know how to do a snapshot. They shouldn't know like what's running underneath. That sort of information, that level of detail needs to be transparent to the data scientist, because they want to write Python code and they want to write a TensorFlow checkpoint, and they shouldn't care how it gets implemented under the hood. And so when I go back to that conversation around how do I build an enterprise AI platform, what's the easiest way to do training and development for my company? A lot of the times I've seen way too many customers start off with Kubeflow and they think I'm just going to do that. But then when they start getting into the weeds of it, they run into issues where, okay, Kubeflow gets me a Jupyter notebook and it can do this. But when I start getting into that, it's difficult to do checkpointing, or I don't know how the storage is managed. The Kubernetes layer underneath, do I do OpenShift? Do I do Rancher? Do I do upstream? Do I do a specific version? Do I go on the bleeding edge? There's a lot of conversations that come up, and there's never a right answer because there are pros and cons to all of this. And then even at the bottom level, do I want a DGX pod with ONTAP AI? Do I want a superpod? Do I want something in between? So those are all table stakes. But when you're really getting into enterprise, you have to worry about the things like who has access to this data? When I am doing checkpointing, what's the governance around that? Do I have single sign-on enabled? Like a lot of these boring enterprise features, things around validation and the legal aspect that your data scientist doing a POC isn't thinking of. That needs to be built into your platform, or you're not going to be able to go to market with it. And then on the other side, when you do go into the development teams, they do most of the times want more than just a Jupyter notebook. That Kubeflow and Jupyter and a lot of that baseline is really good, but eventually they're going to want more advanced features, and you're going to need to build those into the platform. So things like hyperparameter optimization, things like scaling out workloads from one GPU to multiple nodes, things like getting access to the latest hardware. You need to future-proof yourself on that. Otherwise, your platform will stagnate. So these are all like really common problems. Nothing here is unique to NVIDIA. Nothing here is unique to NetApp. These are just the problems that if you want to build an enterprise AI platform, you need to keep all of this stuff in mind. And those boxes on the side are often forgotten about. And so this is sort of where NVIDIA BaseCamp platform comes in. So that is our software layer. It has a cloud-based control plane. So you can go to ngc.nvidia.com, and there's a base command button, and you can submit your jobs. You can manage your clusters, manage your data sets, and sort of see everything running in your environment through this platform. It's the common platform that we use within NVIDIA. We have all of those thousands of users using it. And it has the table stakes, and it has all of these additional features. So want to dive into a few more of these features, because I think from the data science side, my background's more in data science. I think some of the stuff we do is really cool. And not just the stuff we do today, but how quickly we've been pumping out new features and new capabilities into this. So we talk about some of the HPC customers who want Slurm and they want a parallel file system. Well, we can enable those customers with things that are similar to Slurm. So SBatch, SRun, we have compatible CLIs and interfaces built into this platform to enable them. We talked a little bit about, I think Max talked about Rapids. So we have Rapids containers and things like that built in. So if you're a Rapids workshop, if you're a TensorFlow or a PyTorch, we have validated optimized containers for all of these different teams built in. If you are doing multi-node training, we have support sort of out of the box for multiple different types. So you don't have to go in and configure MPI. You don't have to go in and rewrite all of your code to use our specific multi-node launcher. We try to support all of them. Then of course, a lot of people have third-party tools that they want to use, and we enable those. A few of the partners listed here. And so, again, some of those are the baselines, but the important thing there is that as you're building up your enterprise AI platforms, you're not just dealing with that one guy on that one team. You're dealing with multiple people across multiple teams, maybe even across multiple orgs. And so the storage needs to support it, the compute needs to support it, but you also need to meet all of those teams where they are. Once you've met those teams where they are with the tools that are already using, then you can start building it up. So a lot of people use TensorBoard built into the platform. We also have support for profiling. So more advanced profiling techniques using Insight, using telemetry from the storage system.
The DGX Foundry is a SaaS service that anybody could use,
yes,
and that sort of thing. The base command is software that anybody could use, or it's integral to the Foundry, and it's how you manage the Foundry. But is this something that, I as a user of an AI space, I could go and say, I want to use base command as my MLOps tool?
So not yet. So let me jump ahead 2 slides. So this is sort of where we are today. So we have DGX Foundry, which is a managed hardware solution. And we have superpod, which is our reference architecture. Today, if you want access to base command, you can buy it with your superpod. So when you deploy your superpod, you're actually running all of your workloads through the software stack. Or you can get access to a Foundry, and the way you consume a Foundry subscription is through base command. We're hoping to make this more accessible in the future, but this is what we have now. And you can get trial access to it through a program called NVIDIA Launchpad. So if you go to the Launchpad website, there's a trial link, and you can sign up and get access to the software and see how it all works.
And all the, you had a slide earlier where NVIDIA had various solutions, Maxine, DLSS, and those sorts of things. Are they in the Foundry available, or is that something? I mean,
yeah, so that's a good question. So the products that I was showing were actually products. So like DLSS, that's how we do super resolution. That's a consumer. Maxine, that's more of something you would integrate into your application.
4 or 5 solutions there, right?
Yeah, but so we have other things like Tau, which is our transfer learning program, and things like that. And those are being built into the platform. And so
they're available with Foundry. You could go out and use Foundry to access those models.
Yes. So there's models that are built in. There's containers like the Triton container that's built in. And as we build out new platforms, and this is sort of one of the values of both Foundry and Base Command, as we're building out new things within NVIDIA, we first get exposure for those new tools internally in our sort of alpha clusters, but then we push it out to Base Command that anyone has access to. So it's really, on the hardware side, Foundry is the fastest way to get access to the new NVIDIA hardware, because we put it there so that you can get access to it before it's widely available. And then on the software side, Base Command is the fastest way to get access to all of the new tooling. Closing up on the sort of data science features, some of the new, more advanced things we're looking at is how do we build easy hyperparameter optimization, auto ML, transfer learning with Tau, or all of these new platforms that make it easier to do maybe vertical specific things, machine learning, healthcare. How do we make that more easily available? And so a lot of that is available today through containers, but shows up in NGC and Base Command as soon as it can. And on the flip side, maybe the more boring side, but possibly the more important side, are the enterprise requirements. So I'm talking about all of these containers on the back end with Foundry and Base Command. We do a lot of security. So we've got monthly security scans of all of the containers we have in the container registry, alerting and notifications and updates if CVEs and things like that come out. So that's really important that enterprises have something like that in place. Also, a single pane of glass, super important. So if you've got thousands of users, thousands of jobs going on at a time, you need to be able to see not only what team is doing what, who's doing what, but also is my cluster being utilized efficiently? Do I have a lot of idle jobs that aren't consuming the storage or the bandwidth or the compute they've been given? Do I have jobs that aren't using tensor cores? Do I have jobs that are maybe doing too much work and it's a team that is over their quota and I need to go talk to that team? So these are all problems that once you have your enterprise AI cluster, you start dealing with these problems, and some of them can be really difficult if you didn't think about them going into it. So BaseCamp provides that. And then a lot of accessibility features. So we talked, I think, a little bit about MLOps and pipelining. So of course, you need capabilities to do that. For the hardcore Linux people, they're not going to want to touch a GUI. So we give them a CLI and an API to consume. And then for maybe the people who are in the opposite camp, they don't want to touch CLI. Everything should be doable through a GUI. So lots of flexibility. And similar, you want flexibility from the hardware point too. So if you have a small workload that needs only a CPU, you can use that, and you're not consuming a whole GPU for every single thing. And then of course, support, having both in BaseCamp and in DGX Foundry, NVIDIA can act as a central person to come in and support. So we've got NetApp supporting us in the back end for the storage, but as a Foundry customer, there's the sort of one choke point there. Like I said, Launchpad if you want to try it, SuperPod if you want to buy it, and Foundry if you want to get going right away. And so how do you make that decision, right? So I think David touched upon this in his slides around how do I want a DGX pod or do I want a SuperPod? But here are some of the things you need to think about, right? So does your company have DevOps, MLOps capabilities? Can you stand something up internally, even if it's a reference architecture and a SuperPod you're using? You're still going to need to manage it. So can you do that? Do you need it for a year, 2 years, 3 months? How much resourcing do you need? And should that be OpEx? Should that be CapEx?
So with the amount of data that we're talking about,
yep.
How does that stuff get in and out of Foundry quickly? I mean,
yeah, so we have some data connectors built, but this is a real problem, and it's
got to be. Right?
It's something that we're doing a lot of work right now to make it better. We're thinking about things like streaming from an external source and having the data platform work. But right now, I think with Foundry, it's really use case driven. So I think we talked about the big NLP customer earlier, and sort of what they did was they imported all of the data and then it stayed there. And so what this becomes is, if the use case you're doing fits what we have with Foundry now, you can get started in days and weeks instead of months. If not, we can bring the compute to your storage by deploying a SuperPod. So the beauty of the SuperPod is it's a reference architecture, so it doesn't take years and months. It takes maybe months or weeks to deploy. And then Foundry is days or weeks. So it's really workload dependent. So the easiest thing, if you don't have petabytes of data that you need to stream directly to the system to do your training, DGX Foundry is right now like the fastest, simplest turnkey solution you can get. It's based off of the SuperPod reference architecture. So you're going to get the same level of performance that we get in Saturn V and SuperPod, and you're going to get about the same level of performance in your DGX Foundry environment. And it's 24/7 support and SLAs and all of the things that the enterprise folks would need with all of those things that the data scientist is going to want that I talked about. And so what is it exactly? It's a SuperPod-based architecture where we have every customer that comes into a DGX Foundry has their own dedicated storage fabric, their own dedicated storage, and dedicated compute. It's available on a monthly basis. So you can get starting at 1 DGX all the way up to, I think, 20.
What about locations, Adam? So I mean, a lot of this, the governance and all that stuff require data not to move outside of countries. And
Yep. So today we have those geos available, and we are currently looking at expanding. So today it's Silicon Valley and Washington, D.C. We have DGX Foundry environments that we're planning to deploy right now in South Korea, Germany, and Taiwan. And I'm sure there'll be more in the roadmap soon enough. But yeah, because that's a huge issue, right? You've got your data, and a lot of it needs to be compliant to multiple different standards. It needs to stay within the country of origin. And so right now, a big part of this DGX Foundry rollout is figuring that out and putting the clusters where they need to be. And if you don't fit into that, right, maybe Foundry doesn't work, and then you go with a superpod architecture. But you can vet it in Foundry. So that's sort of one of the selling points here is if you have a superpod and you need more compute for a short time period, data allowing, you can expand out to Foundry. Or if you don't want to commit to buying a full supercomputer and you just want to vet the process, you can use Foundry sort of as a staging ground to get your processes set up while you deploy a superpod. And the beauty behind that is the software level is the same. So from your data scientist point of view, they've got a drop down that says DGX Foundry Environment 1 or Superpod Environment 1, but all of the other workflow that they would have to learn is the same. So all of the hardware, the geo, the compliance, how the data is moved, how the data is transferred, none of that makes it way up to the data scientists. It's all taken care of by the infrastructure, by the managed services, and by the software automation. So one more thing I just want to touch on, and then I'm going to jump to a quick demo if I can. So David gave a really good overview of the storage fabric, and I think there were some questions around the 140 nodes. So this is the superpod architecture. So the DGX Foundry is based off of this, and this is the compute fabric. So we've split the compute fabric and the storage fabric such that they're distinct. And what we have here is each SU has 20 nodes into it, and that's connected to an IB switch, a spine switch for the compute. And then we have 7 of these SUs that are connected from the spine switches to the core switches, and each of these has 20 nodes. So we're able to get consistent performance within an SU and then near consistent performance across SUs using this topology. And right now with the switches we have available, this is as big as we can go, but we're always looking to expand this and grow this as new switch equipment comes in, new networking equipment comes in as the new generations of systems are available. And Foundry will become sort of the quickest way to get access to the cutting edge. And so this is going to be completely driven from the GUI. So what we have here is I can create a workspace. So in BaseCamp, there's the object of workspaces, which read write, and then you have data sets which are read only. So I think this question came up earlier, like how do we abstract this away from the customer? Well, we have a click button that says make a data set or make a workspace. So they don't have to know about what the CSI implementation is under the hood with NetApp, because all of the Foundry is powered by NetApp. They just need to see read only. So when it gets to the point where you're creating a job, you sort of specify the environment that you want. So is that a Foundry? Is it a Launchpad? What's the compute requirement you need? Down here, you can see we have multiple data sets available. And so we have access controls on who has access to this data set, a person, a team, an org, or some are public. And you select the data set. You can see some of the metadata, and you just say where you want it to mount within your container. Also, you specify the results, and the results of your training job will end up read-only at the end, and that sort of gives you the full traceability across your data, across your containers that you're selecting. So the runtime environment, the code used, the data sets used, and then the results are all sort of traceable within the platform, sort of like how Mike was talking about earlier.